Welcome to our weekly roundup of groundbreaking AI research. This week, we're spotlighting the top AI research papers that are pushing the boundaries of what's possible. From Google DeepMind's VO3, which brings synchronized audio to AI-generated videos, to ISA4D's innovative approach to 4D human video generation, these papers are redefining the landscape of artificial intelligence. Stay tuned as we delve into each of these remarkable studies, breaking down their unique contributions and what they mean for the future of AI. Paper number 1, VO3, Google DeepMind's leap into AI-generated cinematic storytelling. Google DeepMind's VO3 marks a significant advancement in AI-driven video generation, distinguishing itself by integrating synchronized audio, dialogue, ambient sounds, and music directly with high-definition visuals. This fusion transforms static prompts into dynamic, narrative-rich videos, effectively ending the silent film era of AI-generated content. What sets VO3 apart is its nuanced understanding of cinematic language. Users can specify camera angles, lens types, and scene compositions, and VO3 responds with coherent sequences that exhibit realistic physics and fluid motion. The model's ability to maintain temporal consistency over extended durations, exceeding a minute, ensures that generated content aligns closely with the intended narrative flow. Moreover, VO3's multimodal capabilities allow for the incorporation of reference images and existing footage, enhancing creative control and enabling more precise storytelling. This flexibility positions VO3 as a versatile tool for filmmakers, educators, and content creators seeking to produce high-quality videos from simple text prompts. However, the model's sophistication also raises concerns about potential misuse. Its ability to generate hyperrealistic scenes, including sensitive or misleading content, underscores the need for robust ethical guidelines and safeguards in AI-generated media. Google has implemented measures like digital watermarking to address these issues, but the broader implications for misinformation and content authenticity remain areas of active discussion. In summary, VO3 represents a pivotal development in AI video generation, offering unprecedented creative capabilities while highlighting the importance of responsible deployment in the evolving landscape of synthetic media. Paper number 2, Imagen 4. Photorealistic text-to-image diffusion models with deep language understanding. Imagine describing a scene in words and instantly seeing it come to life as a vivid, photorealistic image. That's the groundbreaking capability introduced by Google's Imagen model. What sets this paper apart is its innovative fusion of large language models with diffusion-based image generation, achieving an unprecedented level of detail and accuracy in aligning images with textual prompts. At the heart of Imagen is the surprising effectiveness of using a pre-trained large language model, specifically T5XXL, trained solely on text data, to encode prompts for image synthesis. This approach revealed that enhancing the language model's capacity significantly improves both the fidelity of the generated images and their alignment with the input text, more so than increasing the size of the image diffusion model itself. The model employs a cascade of diffusion processes, starting from a low-resolution image and progressively refining it to higher resolutions, culminating in images that are not only high in quality but also deeply reflective of the nuanced details in the prompts. This methodology led Imagen to achieve a state-of-the-art FID score of 7.27 on the COCO dataset, without being trained on it, and human evaluations found its outputs to be on par with actual COCO images in terms of image-text alignment. To rigorously assess its performance, the researchers introduced DrawBench, a comprehensive benchmark designed to evaluate text-to-image models across a variety of scenarios. In comparisons, human raters consistently preferred Imagen's outputs over those from other models like VQGAN plus CLIP, latent diffusion models, and DALL-E 2, citing superior quality and better adherence to the prompts. In essence, this paper marks a significant leap in text-to-image generation, demonstrating that leveraging the deep understanding of large language models can lead to more coherent and visually compelling images, setting a new standard in the field. Paper number 3, MVPainter. Accurate and detailed 3D texture generation via multi-view diffusion with geometric control. MVPainter introduces a groundbreaking approach to 3D texture generation by addressing three persistent challenges: reference texture alignment, geometry texture consistency, and local texture quality. Unlike traditional methods that often rely on 2D image diffusion models followed by UV texture reconstruction, MVPainter employs a multi-view diffusion model enhanced with geometric control to ensure that textures are not only high in fidelity but also accurately aligned with the underlying 3D geometry. A key innovation in MVPainter is the integration of ControlNet-based geometric conditioning. By incorporating normal and depth maps as control signals, the model achieves precise alignment between textures and 3D surfaces, ensuring that the generated textures faithfully represent the reference images even under varying lighting conditions and occlusions. To further enhance texture quality, MVPainter introduces a comprehensive data processing pipeline. This includes data filtering based on color entropy and texture complexity metrics, as well as augmentation strategies that simulate diverse lighting and viewpoint conditions. These steps collectively improve the model's ability to generate detailed and consistent textures across different scenarios. Beyond traditional RGB textures, MVPainter extends its capabilities to generate physically based rendering, PBR, attributes, including base color, metallic, and roughness maps. This is achieved through a dedicated PBR attribute extractor that processes the multi-view images to produce PBR meshes suitable for real-world rendering applications. The effectiveness of MVPainter is validated through human-aligned evaluations, demonstrating state-of-the-art performance across all three core dimensions of texture generation. By releasing the full pipeline as an open-source system, including data construction tools, model architecture, and evaluation scripts, MVPainter sets a new benchmark in 3D texture generation and paves the way for future research and applications in the field. Paper number 4: EVA, Expressive Virtual Avatars from Multi-View Videos. Imagine a digital avatar that not only looks photorealistic but also mirrors every nuance of your facial expressions, body movements, and hand gestures in real time. That's precisely what the EVA framework achieves, setting a new benchmark in virtual human modeling. What makes EVA stand out is its innovative two-layer architecture. The first layer is an expressive template geometry that captures the intricate details of human motion and expression. The second is a 3D Gaussian appearance layer, which allows for the independent control of facial and bodily features. This separation ensures that changes in facial expressions don't inadvertently affect body movements, and vice versa, providing a level of control and realism previously unattainable. EVA's tracking algorithm employs a coarse-to-fine optimization strategy, meticulously recovering body motions, facial expressions, and subtle deformations from multi-view video inputs. This results in avatars that are not only visually convincing but also dynamically responsive. The rendering process is equally sophisticated. EVA combines the outputs of its dual modules, mapping them onto a unified mesh. Through dual quaternion skinning, this mesh is animated to reflect the desired poses and expressions. The final step involves rendering the avatar using a technique called splatting, which ensures high-fidelity visuals from any viewpoint. In practical terms, EVA's capabilities are a game-changer for industries like virtual reality, gaming, film, and remote communication. It enables the creation of digital humans that can convincingly replicate real-world counterparts, opening up new possibilities for immersive experiences and interactions. In summary, EVA's unique approach to disentangling and independently controlling various aspects of human expression and movement marks a significant leap forward in the field of digital avatar creation. It's not just about creating lifelike avatars, it's about giving them the expressive depth and control that make them truly human-like. Paper number 5: GA3CE. Unconstrained 3D gaze estimation with gaze-aware 3D context encoding. Imagine a world where machines can understand exactly where you're looking, even without seeing your eyes. That's the groundbreaking promise of GA3CE, a new approach to 3D gaze estimation introduced at CVPR 2025 by researchers from Woven by Toyota. Traditional gaze estimation methods often rely heavily on clear, close-up images of the eyes. But what happens when the subject is turned away or too far from the camera? GA3CE tackles this challenge head-on by shifting the focus from eye appearance to the spatial relationships between the person and their environment. At the heart of GA3CE is the concept of gaze-aware 3D context encoding. Instead of depending solely on facial features, the system constructs a 3D representation of the scene, capturing both the subject's body pose and the positions of surrounding objects. This holistic view allows the model to infer gaze direction based on how the subject interacts with their environment. To make sense of this complex 3D data, GA3CE employs an egocentric transformation, aligning the scene from the subject's perspective. This mirrors how humans perceive the world, simplifying the spatial relationships and making it easier for the model to predict where the subject is looking. But GA3CE doesn't stop there. It introduces a novel direction distance decomposed, D superscript 3, positional encoding, breaking down spatial information into direction and distance components. This nuanced approach enables the model to capture subtle cues about where attention is directed. The results are impressive. GA3CE achieves a 13% to 37% reduction in mean angular error compared to leading methods, all from a single frame. This leap forward opens up new possibilities for applications in augmented reality, driver monitoring, and human-computer interaction, where understanding gaze is crucial, even when the eyes aren't visible. Paper number 6, Custom SVG, Style Customization of Text-to-Vector Generation with Image Diffusion Priors. Imagine being able to generate high-quality, stylized vector graphics from simple text prompts, consistently and efficiently. That's precisely what this groundbreaking paper introduces. The research tackles a significant gap in current text-to-vector, T2V, generation methods, the lack of effective style customization. While existing models can produce SVGs from text, they often fall short in maintaining consistent visual styles across different graphics, a crucial requirement in fields like branding and UI design. What sets this work apart is its innovative two-stage pipeline that harmoniously blends the strengths of feed-forward T2V models with the rich stylistic capabilities of text-to-image, T2I, diffusion models. In the first stage, the authors train a T2V diffusion model using a path-level representation, ensuring that the generated SVGs maintain structural regularity and clarity. This approach focuses on learning the fundamental content and structure of SVGs, laying a solid foundation for further customization. The second stage is where the magic of style customization happens. Here, the model leverages customized T2I models to distill various artistic styles into the T2V diffusion model. By fine-tuning the T2I models with a small set of style images, the system learns to generate SVGs that not only adhere to the textual prompts but also embody the desired visual aesthetics. This fusion allows for the generation of diverse, high-quality SVGs in custom styles through a simple feed-forward process. The result is a system capable of producing vector graphics that are both structurally sound and stylistically coherent, directly from text prompts. This advancement opens new avenues for designers and developers, enabling rapid creation of customized vector assets without compromising on quality or consistency. It's a significant leap forward in the realm of AI-driven graphic design. Paper number 7, MTVCrafter, 4D motion tokenization for open-world human image animation. Imagine a world where animating digital humans isn't limited by flat, 2D representations. That's the groundbreaking leap introduced by MTVCrafter, the first framework to harness raw 3D motion sequences for human image animation. Traditional methods rely heavily on 2D rendered pose images, which often lack depth and flexibility. MTVCrafter shatters this limitation by introducing a novel approach, 4D motion tokenization. At the heart of MTVCrafter lies the 4D motion tokenizer, 4DMOT, a system that quantizes 3D motion sequences into discrete 4D motion tokens. Unlike 2D poses, these tokens encapsulate both spatial and temporal dynamics, offering a richer, more faithful representation of human movement. This advancement allows for more flexible and disentangled control over animations, enabling creators to manipulate characters with unprecedented precision. Complementing 4DMOT is the Motion-Aware Video Diffusion Transformer, MVDT. This component integrates the motion tokens into a powerful video generation backbone, utilizing specialized motion attention mechanisms and 4D positional encodings. The result? Animations that are not only more realistic but also adaptable to a variety of characters and scenarios, from full body to half body, and across diverse styles. The impact of MTVCrafter is evident in its performance metrics. Achieving a fresh at inception distance for video, FIDVID, score of 6.98, it surpasses previous state-of-the-art methods by a significant margin. This leap in quality underscores the potential of 4D motion tokenization in revolutionizing human image animation. In essence, MTVCrafter doesn't just enhance animation quality, it redefines the very foundation of how we animate digital humans. By moving beyond 2D constraints and embracing the complexities of 4D motion, it opens new horizons for creators, developers, and storytellers alike. Paper number 8, ISA4D, Interspatial Attention for Efficient 4D Human Video Generation. Imagine generating photorealistic videos of digital humans that move naturally, maintain consistent identities across frames, and can be viewed from any angle, all from a single reference image. The ISA4D paper introduces a groundbreaking approach to this challenge by unveiling the interspatial attention (ISA) mechanism, a novel cross-attention technique that bridges 3D and 2D representations. Unlike traditional methods that rely solely on 2D projections of 3D models, ISA enables bidirectional information flow between 3D SMPL templates and 2D video frames, ensuring accurate 3D-aware conditioning and rendering. This symmetric design allows the model to perform both rendering, 3D to 2D, and reconstruction, 2D to 3D, within the diffusion transformer, enhancing motion consistency and identity preservation. Complementing ISA is a custom-built video variational autoencoder, VAE, tailored for capturing the rapid and complex dynamics of human motion. This VAE employs spatiotemporal compression and data augmentation strategies to produce high-quality latent representations, facilitating efficient training of the diffusion model. The integration of plucker camera embeddings further refines view control, allowing for precise manipulation of camera angles and backgrounds. ISA4D's architecture excels in generating high-fidelity 4D human videos with controllable poses, viewpoints, and identities. It supports multi-character animations, dynamic background compositions, and maintains consistent facial features across frames. By seamlessly integrating 3D structural information into the diffusion process, ISA4D sets a new benchmark in the field of human video synthesis, offering a scalable and versatile solution for applications in virtual reality, gaming, and digital content creation. That's a wrap on this week's top AI research papers. We've explored how these innovative studies are shaping the future of artificial intelligence, from cinematic storytelling to realistic human video generation. If you found this video insightful, don't forget to like, subscribe, and hit the bell icon to stay updated on the latest in AI research. Share your thoughts in the comments below. We'd love to hear which paper intrigued you the most. Until next time, keep exploring the fascinating world of AI.